Okay, let's start this webinar. And today we are going to have a webinar relating to design for excellence, DFX. Good afternoon. You are warmly welcome to our webinar about the design for supply chain, manufacturing, and testing. This webinar is presented by ATEPLAN and Scanfield. I'm your host, Kari Viitala, and I'm working here as an account manager and in ATEPLAN embedded systems and software development. I work mainly in different product development cases and in various industry segments. And I have personal background more than 20 years in different kind of electronics projects and software projects. I make some practicalities about the webinar. So if you have any questions, you would write those in the chat window, which you find on that GoToWebinar control panel. All questions are answered at the end of the webinar, and this webinar also will be recorded, and you will receive an email and a link to the recording of the webinar. And then I will introduce our speakers, Reijo and Lucas. So Reijo is from Scanfield and works there as a development manager. And Lucas is from our office from Wrocław, and then he's working there as a hardware team manager. Then briefly something about the ATEPLAN, what we are nowadays. We are Finnish engineering service company, and we are one of the leading engineering service companies in Nordic region. Our turnover from 2020 was about 260 million euros, and we have currently about 3,700 employees. We have three main service areas: engineering, which is mainly mechanics design, electrics automation, process automation, and that kind of things. Then we have the software and embedded systems and technical documentation. We are located here in Finland, Sweden, Denmark, Poland, Germany, Netherlands, China, and USA. And we have totally in 75 offices in these countries. And if you have more questions about ATEPLAN and our services, feel free to contact me. And next, I will handle this presentation to Reijo, and he will present us Scanfield and give us an introduction to design for excellence, and also he will show some case examples. Please, Reijo, stage is yours.
Thank you, Kari. So yes, the topics is about DFX, or specifically design for supply chain, manufacturing, and testing. But before we go into that, I wanted to say a couple of quick words about Scanfield as a company. Why we are here is that we have partnered with ATEPLAN on a strategic level when it comes to product development. So we are driving projects together from specification to manufacturing and ready products coming out of the product line, with a specific intention to improve the DFX that is being performed during the development. Scanfield as a company, we turned slightly below 600 million euros last year. This year will be good growth. We will be significantly over 600 million. Personnel around 3,200 end of last year. We are located in Poland, 2 factories, China, Estonia, Finland, Sweden, where we also have 2 factories, Germany, and the US. We have divided our factory network also so that we have sites that are close to customer markets, meaning they focus on higher volume deliveries, and then sites that we call close to customer R&D, meaning that they are working more in the prototypes, NPI, ramp up, etc., and focusing really on offering these DFX services to get the products out to the market. And our offer is quite wide along the entire life cycle of the product, starting from design services, and of course manufacturing is the core for us, but also on the other side of the life cycle, of course, we offer maintenance services. We handle end of life notifications, etc., replace components, whatever is needed to keep the products going. Quick introduction to Design for Excellence, or DFX as it's mostly known. It's of course a quite widely used term, probably well known by all of you, but of course it has fairly different interpretations. If you think of our customer base, for example, everybody is interpreting it a bit differently, and especially the implementations on how to implement DFX as a part of the design process varies quite a lot. But basically, the idea, of course, with DFX is the meaning is that you can replace the X with typically manufacturability or assembly, DFM or DFA, or testing, sourcing, or even cost, DFT, DFS, DFC, etc. But the tools and methodologies are the same, or at least similar in all these different approaches. You shouldn't teach what is the wrong way of doing things, but this is what we typically encounter quite a lot still within our customer base. I call it the traditional way of working. It means that the development and manufacturing are somewhat separated, and there's not so much interaction between them. So what typically happens is that the development engineers start from the concept phase. They do some kind of design, and then make detailed design and drawings, etc., and then a couple of prototype rounds, and test the product. And then when they think it's ready, they give it to the sourcing team. The sourcing guys send out RFQs to a couple of suppliers, and then they select whoever they think is best for that particular product. And in that way, of course, the manufacturing has no impact or very little impact to the design. It could be that we get the last document package from the last prototype round to do what is called DFX analysis, or we give feedback in the NPI phase after we have already won the project and are starting to implement that into our production. And then, of course, the ability to impact the design in that part of the project is very limited. In most cases, it means that if you want to do a change, you have to go back to the drawing board. You make changes to the design, then you make prototypes, and then you test it, and and then after everything is verified, you can implement that into the design and start manufacturing. So basically it means another design iteration with prototypes, verification, etc. And that of course takes not only time, but not only money, but also a significant amount of time. And that's why typically you implement some of the easy changes that we propose, but anything substantial is typically left out, and maybe you think of it when you are designing the next product or something like that. And how we are thinking is what are the ways to bring in the voice of manufacturing to all the phases of the development, starting from the concept design and then all these different design iterations that are done. The vision that we have is that manufacturing is a part of the project from the beginning, and we have people as a part of the development team basically from day one, and this way we can influence the design along the way without causing that unnecessary design iteration at the end. So it means faster time to market, better manufacturability, which translates to cost optimization in the end. So and of course you can think of also the kind of traditional concurrent engineering as a part of this, meaning that you can think of production processes, test equipment, etc. Along the way, and invest and build those in time before the ramp up starts. Some tools that we are thinking of or have implemented in the very beginning. Of course, you don't select all the components in the concept phase, but some of the key components like MCUs, etc. Of course, you analyze and select what you think is best for the project. And for this, we are implementing a kind of component portal. Of course, still today we can bring in our component engineers to guide those decisions, but fairly shortly we are launching a component portal where we open up all our component library from the ERP to customers to see what we are using, what are active, what we have on the stock, etc. And that especially at this time when everybody's talking about component shortages, we think should be very interesting to customers and our development partners. Then of course we have design guidelines that can help the engineers and can guide the design choices to the right direction in terms of manufacturability. And of course technology studies we can do if we are thinking of something new that has not been done before. Then we can study how that fits into our production, what are the benefits, what kind of costs are incorporated, etc. And then of course standardization is important in all aspects in terms of processes and methods, but also components. It's beneficial to use proven components, proven technologies. Then when we go to the development phase, the design guidelines are of course even more important to the engineers. They can on their own make the right choices and follow the guidelines. And of course we in some cases have, for example, participation in the weekly meetings with the engineers, so it's not only a piece of paper, but we can really guide them by that kind of interaction. Same goes to component engineers. We gladly bring them to the project and can secure that we select components that are in the right phase of the life cycle, meaning that they are still available. In our case, typically 10 years after the product launch, because in our customer base, the life cycles are fairly long. And then design reviews, of course, when you make, for example, a prototype design, it's good to run that in the Valor system, for example, and check that the processes that we have can produce that design. And then, of course, not only in a digital form, when we do a prototype, we write down the findings from those series and give feedback, what was good, what was bad, what should be improved. Yeah, of course, tied to prototype series, we have a manufacturing process prep as well. Test planning is of course important, and that kind of test strategy should be thought of all along the way. Early supplier involvement. In our case, it's typically if you have tooling-based parts, plastics, for example, that are injection molded, then it's beneficial to bring that tier 3 supplier to the discussions already in the development phase. Digital twin is something that we are aiming for. We don't have that fully set up yet. We have some parts of it, but we don't have a full digital factory yet, but that is for sure coming. And then the aim, of course, is that in the design transfer phase, there's not so much left to do. You do the standard NPI activities, but in terms of DFX, it's mostly feedback from the pilot manufacturing, and if the previous phases have been done well, then there should not be any major things to talk about anymore at that stage. Tools I mentioned already, Siemens Valor. We are using that. We have implemented it in most of our factories and still continuing the implementation in some of the factories, but basically we can do this for all the products as long as we get an ODB++ package from the customer or from our design partners. What you check typically, test rules, make sure that there are no violations and the product can be tested in the end, and we can of course even turn it into some test programs for flying probe, for example, in fairly quickly. Process preparation for PCB assembly, component placement checks. Then we have also BOM connector capability, where we can quickly check prices of components and issue an indication for the price. Then when it comes to components, we are working with Silicon Expert mostly to verify the bill of material in terms of component life cycles, so that there are no surprises and we don't get EOL findings too quickly, or preferably not at all. And then of course also the environmental compliance is something that you typically check. Okay, then I have just a couple of quick examples left. First one is fairly simple. It's an LED board that we are manufacturing for one of our customers. In this project, it was actually ATEPLAN who was making the product development work. And as you can see on the picture on the right, this product is a kind of green wall that is used in offices, office spaces, etc. And they have a need for LED lighting to keep the plants happy. And the concept had a very long LED board, 600 millimeters almost, and we were discussing it with the factory who will end up manufacturing this product, and found out that such a concept is not feasible at that time, because the machines that we have do not support such panels. So actually we would have had to run the board manually on 2 lines to make this happen. But in the end, we looked into it and found out that actually we don't need to change the design. We don't need to split the board into 2, for example. Of course, always in terms of price, one component is better than 2 components. But what we did, basically, we bought a kind of long board option to the other line that we have at the factory in Pärnu. So we kept the design of the PCBA as it is, and we were able to implement this long board option before the ramp up of this product, made prototypes, and then everything was ready when the time for ramp up came. Then another case, unfortunately, I cannot disclose the product or the customer in this case, but the project was such that the customer had selected a third party for the product development work, and then we were partnering with ATEPLAN to provide test development for the product and the customer, and then the manufacturing is at our factory in Sieradz, Poland. So ATEPLAN did the DFT for this product, and we did the DFM by using the Siemens Valor system. And there's some examples of findings that were the output from Valor, and that we then gave to the customer. This was in connection with I think it was the second round of prototyping. So before starting the manufacturing of the prototypes, we did the analysis, they did changes, and then it was the improved version of that prototype design that we in the end manufactured. But you can see the typical findings: short circuits, clearances, pinholes that can be left in the PCB design because of the limitations in the CAD systems, etc. I think that was my last slide, so now I will hand over to Lukas.
Yeah, thanks, Reijo, about your presentation. Next, Lukas Novak will present how DFX is taken care in product development.
Thank you. Yes, that's right. As ATEPLAN, we are partners to our many customers in developing their devices, products into the market. So we are dealing with the device development R&D phase. And as you can see here on that slide, here is some quite simple representation of the process, product development process that we have in ATEPLAN. We can call it device creation process. So at this stage, I just want to talk about when, in fact, those DFX things start in our process. And I must say that while preparing to this webinar, the presentation from Reijo with his vision was quite inspiring, because the traditional way of working, when we have the development process and then we transfer that into the production when we have NPI, was somehow in my mind as a usual standard way of working. And then looking at his vision, I also took our process that we have quite well described in our system. And I took the process and I was wondering where, in fact, are the points that we really start to think about those DFX aspects. And it turned out that it really starts early. It just needs some awareness and more contacts to our partners, to EMS and other partners that we are dealing with. So starting with DFS, for instance, so design for sourcing. We start the device creation process with some kind of planning or even with pre-study phase, and this leads us to product concept or architecture of the whole device with the indication what kind of components we will use. So we identify key components, we select those, and there is the most of the decisions are made there for those key components, whether that's some kind of microprocessor or system or module or some other key components like Ethernet PHY controller or some even connectors where they are quite special. They also could be key components. So we identify those, and that's the starting point when we take care of the design for sourcing. The next point, if you think about design for manufacturing, it also starts quite early, maybe not as early as planning phase, but in the design and verification phase when we design schematic or PCB layout. First, we also have rules in our CAD tools that define those rules for the manufacturing, but we also very often make a DFM workshop. So and this depends on the product itself. I will go into details maybe later, but that's again the beginning of the design and verification stage in our process is the point when we start to think about that. And then when you go for design for testing, this can also start very early. So when we think about product requirements, what kind of product do we need to develop? What are the volumes of this product? Is it a mass volume product or just some kind of special application where it will be used, and what kind of testing needs are there? So should we test all the functions in details, or do we need only some kind of overall functional testing at the production? Is it safety testing involved there? So there are many questions that we ask at the very early stage, and this results in product requirements and in the test strategy. And now we can go deep into each of that. So thinking about design for supply chain, as I mentioned, we think what is the product, what's the architecture, and what's the components needed for the design. That's the point when we identify those, and yeah, thinking about our recent projects, we do that very often, that we also secure key components with our suppliers very early. So we are sure that we will have the components available for prototype productions and also for the serial production that will eventually happen. So to check the life status, so we also have tools for that, like Silicon Expert or some online tools. And also maybe not mentioned here, but very important source of information are also our technological partner or semiconductor suppliers and their field application engineers that we are very often in contact with while selecting those key components. And then we of course need to check the availability, as I mentioned. So we have our EMS partner that is also very helpful in that matter. Other aspects of this design for supply chain, yes, we have some key components, and also when we have our design libraries for the standard parts or for most of the parts, we take care that we have alternative parts in the library that we can use during the production. So we have those key components secured, and then most of the parts should have some alternative parts. But of course, that's not the case in some special circuits. So if really needed, I would say that's also is happening, maybe not very often, but it's possible to design a redundant circuit using similar component with similar functions and place it on the PCB, on the schematic. And then in case of sourcing issues, alternative component, which is not a pin-to-pin, but similar in function, can be used to maintain the supply chain. Okay, and now we can go to the next point. So design for manufacturability. And here, as I said, there are two main aspects. One is that we have also rules or some kind of knowledge from IPC standards or some experience that we have, and those rules we can implement into CAD tools and then verify those during the design. But those rules and this knowledge is not always up to date, and sometimes we have very special cases for the product. Therefore, we very often do those designed for manufacturing workshop with manufacturing partner. And here the focus can be on each of that level. So PCB or PCB assembly or the product assembly as a whole. So for the assembling the PCB into housing or wiring. So not only 3D modeling when we have conflict resolved or some clearances or safety clearances taken into consideration, but also when we think about the assembly of the product, we need to think how to design to make the assembly easier. Okay, and last thing that I can tell is design for testing. And as mentioned before, this happens very early when we think about the test strategy, and so we need to know and think in details what kind of product is that, what are the features, what is the volume and expected yield, what's the cost of this kind of product, cost of repairs and this kind of subjects. So then we can focus on the test strategy for the PCB, for the PCBA, and also for the whole product. And here for the PCBA, similar to manufacturing, we have knowledge from standards. We can check the testing coverage using ADA tools that we have. Similar for the assembled PCB, this can be done both ways with the ICT that is that's checking the component assembly on the PCB, and then followed by the functional testing that checks the PCBA or the complete product. Also, what is sometimes overlooked but important is how to make the design easier for the PCBA tester. So we had several cases where our customers were asking for the analysis of the existing products and how to improve those in terms of making them easier for the production testing. So what should be the PCB like, or how should it be designed, and are there any mechanical constraints or electrical interfaces there, so we can then make the testing process in the production fixture much easier. And lastly, here is one of the example that somehow is very, I think, significant from the cost point of view. And this is an example for the PCB itself. So for the manufacturing of the PCB, we had a project when we designed quite advanced multi-layer board with high-speed signals. And it really required a lot of high capabilities for many aspects. So not only one aspect like copper thickness or copper clearance, but also many layers, quite thick board. So also very high requirements for the drilling. We also use their technology called back drilling that is used in the high-speed signals. And we had several discussions, or we were also selecting a proper supplier for this kind of board, as the requirements were very high. And while discussing with the suppliers, we realized, and also suppliers realized, that okay, when even we follow the rules into the one parameter like clearance or drilling diameter or the thickness of the PCB, all together combined would result in very low yield for the PCB manufacturing. Therefore, we had discussions, workshop, what can we do to reduce the requirements for the PCB manufacturing and keep the technical aspect of the PC boards at the same time. So as a result, we've, for example, reduced the numbers of layers that should be back drilled. We simplified the design, and we focused to redesign the board in such way so the number of the back drilled layers is reduced, and it made the design easier for the manufacturing at the end. And okay, so for the summary from my side, key points and the most important points are that as a design house, design company, we feel that DFX is in our responsibility, and in fact we have it incorporated in our process in many stages and many points, as you could see. We in fact implement those DFX aspects from earliest stage possible. We have also our rules, our libraries, some knowledge from the past, from the standard, but this is not enough. We need to contact and discuss with our suppliers, with our partners like Scanfield, because they have the most recent experience, and yeah, they deal with that subject more often, so they have the hands-on experience. And yes, so we also use partners for the prototypes production, so we can verify the design there. And that would be all from my side.
Okay, thank you, Lucas, from your presentation. So it seems that we have question. There is currently no questions in our chat, but I think that we are going to end this webinar over here. But I would like to thank our participate audience and also our speakers from very interesting presentations. So if you have any questions later on, you could contact me or our speakers via email. And thanks to everybody, and bye-bye.
Thank you.
Thank you.